Good evening all. Am I audible? Good evening everyone. Am I audible? Good evening all. Am I audible? Good evening all. Am I audible? Yeah. Sudarshan, good evening. Venkateshwaran, good evening. Kirtana, good evening. So yesterday I go through the assignments. I think there are around 70 to 80 members have posted their assignment. So today is day 10, right? So you will be assigned for next assignment. Today you will get your second assignment. Let's talk about the second assignment in the last few minutes. Shall we wait or shall we start the class? Is it clear? Shall we start the class? Let us wait for a few minutes for the remaining members. Muthu Ganesh, good evening. Shall we start? Are you guys are ready? Okay, so today's topic is gas leakage detection using Arduino IoT cloud. So in previous classes we have interface of sensors and we have using ThinkSpeak cloud, Ask Sensor cloud and web server. So today we are going to use Arduino IoT cloud. We are going to write program in Arduino. We are going to Arduino IDE. And also we are going to use the Arduino IoT cloud. So compared to the previous web servers and cloud, it is a bit easy compared to ThinkSpeak or Ask Sensor. You can write the code in the cloud itself. Okay, so let me start. First, gas leakage detection using Arduino IoT cloud. So gas leakage detection using this cloud is a fascinating topic that combines the power of Arduino microcontrollers, IoT technology and cloud computing to monitor and detect gas leaks in various environments. So this system offers an effective solution for ensuring safety by promptly identifying and alerting individuals about the presence of dangerous gases. So now let me give a brief introduction to the key components and concepts involved in this gas leakage detection using Arduino IoT cloud. So first, Arduino. So it is an open source electronic platform. You already know that, right? So that provides a range of microcontrollers and development boards. So Arduino boards are widely used for prototyping and building electronic projects due to their ease of use, due to their affordability and vast community support, right? So the sensors such as MQCD sensors can be utilized. Then coming to IoT, the Internet of Things refers to the interconnection of various devices and systems through the internet. So in gas leakage detection, IoT technology allows the gas sensors to communicate with the Arduino board and transfer data to the cloud for further process and analysis. Here we are going to use ESP8266 board, not Arduino board, not that. Then coming to Arduino IoT cloud. So it is a cloud based platform provided by Arduino that enables easy and secure management of IoT projects. So it simplifies the process of connecting and controlling Arduino devices remotely. So with Arduino IoT cloud you can monitor and control your gas leakage detection system from anywhere using a web browser or a mobile application. And then coming to cloud computing. So this involves storing and processing data on remote servers instead of on local devices. So in this context of gas leakage detection, cloud computing allows for real-time data analysis, storage and remote access to the gas sensor, readings and alerts. So by combining these elements, a gas leakage detection system using Arduino IoT cloud can continuously monitor the gas level in an environment and provide alerts through various means, such as you can get a notification from email notification, SMS messages or mobile app notifications when gas level exceeds safe threshold. So now let's see the gas sensor. So the model name is MQ2 gas sensor. So this is a widely used gas sensor module capable of detecting various gases including LPG, propane, methane, hydrogen and carbon monoxide. So it operates based on the principle of chemi-resistive technology, where the presence of a specific gas alerts the electrical resistance of the sensor. So the MQ2 gas sensor typically consists of 4 pins, each serving a specific function. So first one is VCC. Here it is. So this pin is used to provide power to the sensor. So it is usually connected to the 5-volt pin of the Arduino or ESP8266 microcontroller to the power supply. So you should connect this pin to V-in of your ESP8266. And then coming to ground. This is the ground connection of the sensor. It should be connected to the ground pin of the ESP8266 or the common ground of the circuit. And it has both analog output and digital output. In this session we are going to use analog output, not digital. So A out, analog output. This pin provides an analog voltage output that corresponds to the gas concentration level which is detected by the sensor. It can be connected to one analog input pin of the Arduino for reading and further processing. And then coming to D out, which is a certain threshold. So the D out pin can be connected to a digital input pin of the ESP8266 microcontroller. So this is about MQ2 gas sensor. Is it the Arduino IoT setup? For that, go to Google and search Arduino IoT Cloud. You have to select from the official site. So Arduino Cloud. So if you don't have your Arduino IoT Cloud in the sense, just log in using your email ID. Now click Arduino IoT Cloud. Here it is. So here we are going to first, what we are going to do is that we are going to create things. So in this session we are going to interface MQ2 gas sensor with ESP8266. Okay. So just we are going to create thing first. So just click this create thing. We need to configure 3 things inside the thing. Under things we are going to do three steps. One is we are going to add variable, then we have to add the device, then we have to add our network credentials. So before that, here you can change name like IOT based gas leakage detection. This is our project name. So first what I am going to do is that I am going to add variable. So here we can give gas underscore data. So what is the benefit of this in the sense we don't have to write the full code. So I will explain it later. We are adding variables in the code itself, right? So before that we are creating the variable using these three steps. So first I am adding variable which is gas data, and it will ask for a variable type which is basic type. Here I am going to select the integer. This. So it will create itself like integer gas data. I don't want to change anything here, but we are going to read the sensor. So just give add variable. So it will create it here like this. Now what we are going to do is that we are going to select the device. So we are going to set up a new device. So we are not using Arduino. We are going to use ESP82. I am going to use ESP8266, right? So click this and select the model 12E Node MCU 1.0 ESP12E module we are using. So select this and click continue. Here we can give ESP8266 gas sensor. Click next. And after that you will get your device ID and secret key. We are going to use this in our code, and we are going to use this secret key in network credential for form like this. We can also download this, otherwise just copy this and paste it somewhere. We are going to use in our code later. So let me paste it in a notepad, okay? So copy this. So device ID, I am going to paste it here, and also secret key. This is our secret key. Okay. So now I saved my device ID and secret key. Click continue and done. Now we have successfully added our associated device. Here it will your type and status is offline. You can change this also. Now what we have to do is we have to add network credentials. So configure this, your Wi-Fi name, and you have to give your password here, and here you have to paste your secret key. So copy this and paste it here. Now click save. So it will show like your Wi-Fi name, password and your secret key. After pasting your secret key, now it will show like offline, right? So after we have to do one more step, then it will show like it online. Now what we are going to do is that now let us move to the sketch part. We have added a variable, we have added the device, we have added our network credentials. Now what we are going to do is that we are going to do program, but not in Arduino IDE. In Arduino IoT cloud platform itself we can write code. For that you just click sketch here. So open full editor. So this is how the page look like this. So Arduino cloud itself create a code like this. So we will get our integer gas data variable, everything and all. You don't have to open your Arduino ID. You don't have to write the code from the scratch itself. You just have to mention your pin. And what we are going to do, we are going to read the sensor, right? So we are going to read it and we are going to store it in another variable. That's it. So this pin mode, we are using A0, right? So A0, not A0. Sorry, wait a minute. Yeah, gas sensor, we can give like, okay. So pin mode, we are using A0, which is input. So here I am going to store our pin number, which is A0. So you can give the gas sensor here also. V. Yes. Now inside loop, I am going to, under gas data, I am going to read this gas sensor. So that's it. So here we are going to store our data, which is gas data, and gas sensor pin is A0. We have mentioned here, which is input. And I am going to read that gas sensor using analog read function, and I am going to store the data in gas data variable. So that's it. So here they have provided a function called void on gas data change. So if you are write your code, like if you want to set a threshold, or if the threshold exceeds the some value, you want to receive a mail, SMS, or message, you can provide a code here. So now we are just going to monitor the gas detection. We are not going to do any alert like. So for that purpose, I don't give anything. I don't want to give anything inside this. Just I am going to read the sensor. I am going to store it in a variable. Is it clear? Let me check it first. So click verify. Wait for a few seconds, it is checking. Yeah, save down here. So our code is error free now. So to upload our code from web editor to ESP8266 microcontroller, we need to install one software which is called Arduino agent. If you are writing code in Arduino ID, in the sense, you don't need anything, like you just click upload button and the code will upload to your microcontroller. But in web editor, we need to install one software called Arduino agent. Just go to Google and search Arduino agent download. So here you can get from official website also. So just by clicking this, here you will click start and you can download it. So that's it. So after downloading, just extract the file and you will get your Arduino agent here. So it will show a symbol like this. So agent is nothing but it's the agent between your web editor and controller. It is used to upload your code from web editor to your microcontroller. So now we have to select the board and port. Here I have selected Node MCU, ESP12E module and our port is component 4. Click this. Now we have to upload the code to our microcontroller. Before uploading the code, make sure that you have started your Arduino agent. Now it shows like sparse agent, right? So it's already started. So make sure that it is start or stop. So it is uploading. And I have already connected the component here. This is our MQ2 gas sensor. The A0 is connected to the A0 of ESP8266 and the positive pin is connected to VIN and ground pin has to connect the ground of the ESP8266. This is all about the connection. So it's uploading. Upload it again. Yeah, I have received all your assignments, but don't forget to copy your assignment link and you have to paste it in a Google form. Don't forget to do that. You must copy your assignment link and you have to post it in the Google form. If you guys have any doubts regarding assignments and the how to post everything and all, you can just ask me. Yeah, it's done. Now what we have to do is that now we have to set the dashboard. So for that, go dashboard. So we are going to build a new dashboard here. So if you want to give anything in the sense, you can give like monitoring. I'm going to give, we are going to monitoring gas leakage. So we are going to add gauge here. So click add. Here we will get so many options like switch, push button, slider, stepper, and we are going to add gauge. So if you want to link your variable here in the sense, you can link your variable. So we have already created gas data, right? So if you want to link in the sense, you can. And here you can give the minimum and maximum value. The default set by 0 to 100. That's it. Click done. That's all. So here we have seen coding part, and in dashboard we have created the dashboard. Here you can monitor your gas sensor. That's all about. And if you make some smoke in front of the gas sensor, you will get to know the variation here. But now I didn't make any smoke in front of the gas sensors. So if you want to see the output in the sense, just make a smoke like using matchbox or something. You can see variation here. So that's it. This is all about the gas leakage detection using Arduino IoT cloud. Is it clear? Do you have any doubts regarding this? If it is clear in the sense, just drop S or thumbs up emoji in the chat box, please. Is it clear? Is it clear, everyone? Is it clear? Do you have any doubt regarding this? If everything is clear in the sense, just drop S in the chat box, please. So this is your 10th day second assignment. So you can pick any interface from day 6 to day 10. We have seen 5 interface, right? DHT11 sensor interface, ultrasonic interface, and we have seen also soil monitorization and event management system yesterday. So today we have seen gas leakage detection using Arduino IoT cloud. So we have used ThinkSpeak, Ask Sensor and Arduino IoT. So you can pick any of these 5. You can pick any one. You have to write the code and you have to verify it. Just took a screenshot. If you have components with you in the sense, you can do interface also. Just took a picture of it and post it in the Facebook group or LinkedIn group, and don't forget to copy that link and paste it in the Google form. I will provide you the Google form in after 2 days. So today is Wednesday, right? So you have to submit your assignment within Friday. Don't take too much of time. Please try to submit your assignment within Friday. Do you have any doubts regarding this? Is it clear? I'm asking about the from day 6. Do you have any doubts in the previous classes? Is it easy to learn? Just drop your answers in the chat box, please. Do you find any difficulties while writing the code or doing interface, installing the softwares and everything and all? Do you have any doubts? If you have any in the sense, you can ask me. Is everything clear? Yes, I have gone through all the assignments, but I will check it again. Wait for a few seconds, attendance link will be provided. Yeah, attendance link will be posted now. Wait for a few minutes. So tomorrow onwards, for the next 3 days, we are going to see communication protocols. Have you heard about communication protocols, UART, SPI, I2C and everything and all? For the next 3 days, we will see So this is all about today's class. If you guys have any doubt in the sense, you can ask me. So yeah, thank you everyone. Let's catch up tomorrow's class with different topic. We are going to see communication protocols from tomorrow. Thank you all. Have a great day.